Okay, let's dive into this. Welcome to This Explainer, where we're going to unpack what is honestly one of the most thrilling, action-packed stories in the history of our entire planet. I mean, we're talking about a story of record-breaking speed, total cataclysmic destruction, and the birth of the world's greatest mountains. Today, we're exploring the epic voyage and the birth of the Indian subcontinent.
So, how on earth did a piece of land that was literally attached to Antarctica 250 million years ago end up causing devastating earthquakes in modern-day Nepal? Right? It sounds like a complete geographical paradox. No way that makes sense. But to answer that, we've got to take a massive chronological journey back in time.
Here's a quick roadmap for our story today. We're going to start 250 million years ago with the Pangaea supercontinent, track the Indian plate as it breaks away from Gondwana, witness its explosive volcanic phase 65 million years ago, its massive collision with Asia, all the way down to the actively growing Himalayas today. Let's get into it.
Part 1. The breakup of the supercontinent.
Picture this, a lush, green Earth completely devoid of borders. Just one massive landmass called Pangaea, totally surrounded by a single colossal ocean named Panthalassa. You've got dinosaurs, early crocodiles, and ancient cockroaches roaming freely across this one unified world. But as we know, Pangaea didn't stick around. To understand why, we have to look at the mechanics of continental drift. Deep inside the Earth, the core is basically as hot as the sun. And this immense heat warms the rocks in the mantle, causing them to rise. As they hit the cooler crust, they sink back down, creating these massive convection cycles. These cycles literally act like giant conveyor belts, and they eventually tore Pangaea right down the middle into two massive pieces, Laurasia in the north and Gondwana in the south, creating a giant trench of water between them called the Tethys Ocean.
Now, back in 1912, a German meteorologist named Alfred Wegener presented this exact evidence, and people thought he was absolutely crazy. But look, the evidence was undeniable. Think about it. We found fossils of the Mesosaurus, which is a freshwater reptile in both South America and Africa. It is physically impossible for that little creature to have swum across the modern Atlantic Ocean. We also found perfectly matching ancient rocks on the coasts of Brazil and West Africa. Plus, just look at a map today. The continents still fit together like giant puzzle pieces. He hit the nail on the head.
Part 2. India's high-speed ocean race.
Now, what's really interesting about this next part is, around 130 to 140 million years ago, the Indian tectonic plate breaks off from the southern supercontinent Gondwana and just starts heading north towards Asia. But it didn't just drift, okay? It sprinted. While other continents like Australia and Antarctica were kind of just dragging along at a leisurely 4 to 5 centimeters a year, India was rocketing across the ocean at 18 to 20 centimeters per year. It was moving 4 times faster than the rest of the pack. So, what was the rush?
Well, the secret lies deep underground. Scientists discovered that massive mantle plumes, these are basically jets of superheated rock shooting straight up from the Earth's core, hit the crust right beneath the Indian plate. And this intense heat literally melted off India's deep lithospheric root. Think of it as melting off a ship's heavy rocky anchor. So, while other plates stayed heavy and thick, up to 300 kilometers thick, India was shaved down to just about 100 kilometers. It became incredibly thin, remarkably light, and just an absolute tectonic speedster.
Part 3. Did India kill the dinosaurs?
Okay, we all know the famous story of the massive asteroid, right? But the source material here presents a completely unexpected perspective that kind of forces us to rethink Earth's greatest extinction event. As India raced over those superheated mantle plumes we just talked about, the crust cracked, and this triggered some of the most massive volcanic eruptions in Earth's history, creating the Deccan Traps in modern-day Maharashtra. According to research from the University of Michigan and Princeton, these eruptions were spewing out poisonous gases and highly toxic mercury right into the atmosphere. The sulfur from the lava literally turned the oceans into acid. This devastation affected 60% of Earth's entire population. And the most shocking part, this apocalyptic scenario started 4,000 years before the famous Chicxulub asteroid ever even showed up.
Which brings us to a pretty startling conclusion. The Chicxulub asteroid, which, by the way, was an impact 10 billion times stronger than a nuclear blast, certainly delivered the final blow. But the Earth was already dying. The Indian plate's volcanic activity had already started the job. The asteroid, it merely finished it.
Part 4. The crash that built mountains. So, leaving the dinosaurs behind, let's fast forward to about 50 million years ago. To really picture what happened when this hyper-fast Indian plate finally smashed into the heavy, unmovable Eurasian plate, imagine two cars colliding head-on. what happens to the hood, or the bonnet, of the cars? It crumples and it folds upward. Well, this exact geological process happened on a planetary scale. As India smashed into Eurasia, the immense pressure took the ancient seafloor sediments of the Tethys Sea and just crumpled them upward, giving birth to the towering fold mountains we now know as the Himalayas.
And guys, this leads to one of the most mind-blowing facts of this entire story. When you look at the black rocks of the Trans and Greater Himalayas, you aren't just looking at stone. You are literally looking at the compressed, fossilized remains of ancient sea creatures from the vanished Tethys Sea. The absolute highest peaks on planet Earth are made of dead ocean life that was physically pushed into the sky. That is just incredible.
Part 5. The Ultimate Climate Shield.
Now, this phenomenal ancient crash isn't just cool history. It's the sole reason human civilization actually thrives in the subcontinent today. See, the Himalayas act as this massive wall. They block bone-chilling, dry Siberian winds from the north, which keeps the subcontinent warm. Then during the summer, they trap low-pressure moisture coming off the Indian Ocean, forcing it to fall as heavy rain. That creates the vital summer monsoon that feeds millions of people. Geopolitically, they act as a permanent, impenetrable security barrier. And perhaps most importantly, they store life-saving fresh water in their massive glaciers.
8,848.86 meters. That is the staggering height of Mount Everest. To put that into perspective, it perfectly cements the sheer, awe-inspiring scale of what this tectonic collision actually produced. It is literally the towering roof of the world, providing water to 22% of the global population.
But, there is a very terrifying flip side to this. 75%. According to recent climate change projections highlighted in the sources, 75% of these vital Himalayan glaciers could melt in the coming decades if global temperatures just keep rising. And this isn't just a loss of pretty scenery. We're talking catastrophic floods, massive landslides, and eventually severe freshwater shortages. It's a stark warning that we absolutely must protect what took millions of years to build.
Part 6. The journey is not over. Because look, this isn't just ancient history. It's a live event happening right beneath our feet as we speak. The Indian plate never actually stopped. It's still sliding under the Asian plate at a rate of about 5 centimeters per year. And because of this continuous crumpling, Mount Everest is literally growing 1 centimeter taller every single year. But of course, this relentless tectonic pressure also has tragic modern consequences. It's the direct cause of devastating modern earthquakes, like the tragic 7.8 magnitude earthquake in Nepal back in 2015. The Earth is still fiercely alive.
Which leaves us with this final, completely mind-bending thought. According to geological models, in about 250 million years, the continents are going to smash together once again to form a brand new supercontinent called Pangaea Proxima. Imagine a future where you could literally just walk from India to America. No way, right? But it is absolutely wild to think about where our dynamic planet is heading next. Thank you so much for joining me on this explainer, diving into the epic birth of the subcontinent. Catch you next time and keep exploring.